Yeah, so we are live, and I am Praveen Kumar, IOT curator at Zubi, and today's webinar will be covering decoding Internet of Things. So let's start with the webinar. So we'll be decoding what Internet of Things is and how its application is varied into different domains and how you can actually create IoT devices. So let's begin. First of all, let's clear out three things first: when, how, and why. These are the three important things that you should always know about any emerging technology or any existing one. First, when. In 1999, the term coined by Kevin Ashton, IoT was coined by Kevin Ashton in 1999. And then, how. It was a Coca-Cola vending machine. So the problem there was that in Carnegie Mellon University, the problem was that there was a vending machine and it always ran out of Coca-Cola. So the students had a problem that it always ran out. They were never able to get an available stock out there. So they wanted to refill time to time on its own. So what they built for that problem statement is that they actually added a microcontroller, and they, when the Coca-Cola was there, a flashlight would blink for about 3 or 4 times, and then it flashed red. And when it flashed red, it would actually give an order for a new set, for a new stock of Coca-Cola. So it would actually get renewed on its own, and if it's not available, it will get refilled on its own. And no one has to actually go there and actually see every time, because this was not very consistent. No human was actually going there and checking out, okay, stock is not there, let's order. And that is why this gap was there. So necessity creates innovation, and that is how IoT was born at Carnegie Mellon University. And why? The very basic question for any technology is why? To simply make things smarter. So what they did is they made the vending machine very smart, and that is what they did. So yeah. Now we move on to defining it without using any jargon. So we are not using any industrial terms. Let's just break down massive content on internet into simple, basic fundamentals. So right now, what is happening is, using internet, we are able to communicate with each other. Humans are able to communicate with each other using various protocols: HTTP, UDP, TCP, and there are various other protocols through which we actually contact. Right now, also, I'm contacting you through a video conferencing solution. So we are able to do that since a long time. But our our physical commodities in our house, or everything that we say, are they able to communicate with each other? Are we able to communicate with them? So what I mean by that is, I'm going to explain it later. So we actually are entering into the world where everything can communicate with each other. So yeah, the IoT ecosystem. IoT device is not just a device, it is an entire ecosystem which consists of four elements. So let's begin with it. An IoT ecosystem consists of web-enabled smart devices that use embedded systems. Embedded systems consist of two major terms: microcontrollers and microprocessors, that we'll actually be covering afterwards, such as processors, microcontrollers, sensors, and communication hardware to collect, send, or receive data. And these three elements define the entire architecture of it: to collect data, to send data, and to receive data. Fine. These devices share the sensor data they collect by connecting to an IoT gateway. Now, to understand what I'll be explaining later on, you must know what IoT gateway is. So, yeah, just a second. IoT gateway is nothing but your router or the internet connection that you're giving to the hardware module. So, suppose there's an IoT device at your home or at your workplace. So you are going to connect it with internet, right? So you connect it with your office's internet, or you connect it with your home network. So that is what is happening right now. So this is known as IoT gateway. Now we move on to, sometimes these devices communicate with other related devices and act on the information they get from one another. So suppose if I am telling you that two coffee machines communicate with each other, or say your shoes communicate with your friend's shoes, what is happening in this case? The coffee machine and the microwave or any appliance in the kitchen is actually communicating with each other. So suppose your doorknob has an ultrasonic sensor, and you enter your kitchen and it detects that you are here. And this is the time when you actually start making your coffee. So it actually starts up on its own and starts grinding your coffee seeds, and actually it starts the initial process of it. So this is called automation that is happening with the help of IoT. Yeah, so now we break down into the architecture of it. What are the components involved and how it actually takes place. So on the right hand side, you can see there are sensors, the various sensors. These are the crucial elements of an IoT device. So sensors are there, temperature, ultrasonic, or say humidity, or say SpO2 sensors. There are n number of sensors in the market which can be integrated to the new Wi-Fi modules that are available. So these devices are connected to the gateway, as I said, the connection that you're giving it to it, the devices, and then data from the gateway goes to the endpoint. The endpoint is your cloud infrastructure or your database or the third-party IoT architectures that you're using, such as GCP, Microsoft Azure, that I'll be discussing later on. And then after processing, it goes to the user. The user can see it, the user can analyze it, and the user can take immediate action upon it. And this is a two-way communication flow. So I'm saying that sensor to gateway, gateway to database, database to user. This can happen both way. The user can press a button, it goes to the database cloud, then it goes to the gateway, and then the command, the instruction goes to this microcontroller to, okay, take this action. The temperature is rising, okay, start a machine, start an air condition, or any device which could actually bring it down. If the parameters are beyond threshold, control it. That is what is happening in this case. Yeah. So the components involved, the actual technical components involved in an IoT device, let's see what it is. First, microcontroller. Microcontrollers define what IoT is right now. It also, in place of microcontrollers, you can use microprocessors or system on chips. These three can be used. So there are various types of microcontrollers, AVR, ARM, PIC, 8051. There are various kinds of microcontrollers available for industrial use. Then we move on to Wi-Fi module. What an Wi-Fi module is, this will enable that microcontroller locally to send data to the World Wide Web. This is the thing that is creating the major impact in this architecture. And since the last 10 years, the cost and the availability of these ESP8266 Wi-Fi modules have been grown, and the cost has actually shrunk. So if you like go to the market right now, you can actually buy this for say 300 or 400 rupees, and it could make your device much more smarter. And then we move on to the element which connects our local devices to the user, the main thing. And what is it? The endpoints. The endpoints can be your manual configured PHP, or you can use any kind of databases, MongoDB, Django, or you can use the framework Django from Python. And you can use this to actually store and process this data. So what I mean by that is you are getting data. Suppose you are getting temperature as say 98 degrees Celsius right now, or 50 degrees Celsius, any kind of such data is there. But what will you do with that? That is the temperature of a particular second, but you have to calibrate upon it. You have to actually see the trend that is being followed. In short, you need analytics there. And for that, you actually need these architectures. You can manually build it, but it actually requires a lot of effort and time. But as IoT grew, these bigger companies like Microsoft, Google, and IBM, they have come up with pre-existing IoT architecture, which you just need to integrate with your existing device, such as Node MCU, Arduino, or these Wi-Fi modules that are there on the screen. And you can actually simply integrate with API keys and add the tokenality. So what? So now what will happen is you have the IoT device, you are sending data, it goes to suppose say IBM Watson IoT's framework. There's a dashboard that you will get. It goes to there, and then you can see what data is being logged. You can see the analytics of it, that how what trend is being followed with the data. And further on, it can be showed on a front-end platform. So for the front-end platform, it is not necessary that you add a front-end platform to your IoT structure, because sometimes data wants to be processed in the backend only. Suppose for enterprises, for oil and gas industry, or for heavy industries, they actually don't show their data on a front-end platform to the user. It has to be managed in their company and within their authority, right? So front-end platform is an optional element in IoT devices until and unless it is going into a consumer industry. Front-end is just optional and can be built with React, Angular, Vue, or various other frameworks that are there. Yeah. So any questions I could help with? I have a Fitbit for dogs. Can I understand my pet behaviors? Sure, sir. So there's a girl from Chandigarh, I guess. She built a device which could actually be worn by a cow or a pet, and that entire it was just like a cloth or a cow, the normal wear that a dog or a pet can wear. That was there, and when the dog won that, it would actually sense the behavior of the dog, not the body temperature and these parameters were uh, the primary concepts of it, that okay, the body temperature is this much, and what actually such as so there are certain parameters that you have to actually sense from a pet that is there. Those were there, and actually the behavior of it, behavior of the dog, that how is he behaving, where all he's going, the geotagging of him, and all this data was collected, and then it could be stored in a microchip. So this was there. But now if we apply IoT into her solution, I must say that her solution was actually published in Cambridge University's research, and she is right now in Cambridge University, I guess, and her solution is patented. It's totally a novel approach towards care for dogs and pet animals. And if we apply IoT into it, what actually is happening with the pet, she can know from anywhere around the world. If she goes on a trip to Mexico or anywhere, she could actually know what her dog is doing right now, or how its health condition is, and all that can be known. So yeah, these devices are not yet deployed into the market, but it could be there. Yeah, absolutely. I hope that answered your question. Thank you. Yeah, so we move on. Now I am covering embedded systems. Embedded systems are the vital element of an IoT device. It creates the IoT device because IoT is nothing but embedded systems connected to the internet. And then there are two major fragments of embedded systems, microprocessors and microcontrollers. So what microcontroller is a standalone module that you add to your sensors, you connect your sensors with it, and is the heart of the embedded systems. It has various input output pins. You connect it with the sensors, you connect it with the actuators, relay modules, and certain other things. Memory and input output devices are present, and it has a quite a very genuine amount of memory into it. Not much, but yeah, it is capable of sensing and streaming the data. But with comparison to microprocessors has a higher memory, has a higher RAM, as well as it is able to process various processes at the same point of time. That is what a microprocessor does. It has a lot of memory and a lot of input output ports. And then moving on to the viability of both, microprocessors can be used not cannot be used for compact systems. Microprocessors are big, and it will be quite a hassle for you to actually adjust it into a compact system, whereas microcontrollers can be easily integrated with the compact systems, or say wearable devices that you wear, or say smart bulbs, smart home automation systems. In these systems, microcontrollers are there. Yeah. So I'm going to show you a live demo of how an IoT system works. So yeah, just a second. Yeah, so this was one of the projects that I created during a hackathon, and it is actually the entire setup for a patient monitoring system, right? Suppose right now in this era of COVID-19, where everyone is actually tense due to what is happening right now, and everyone wants a solution to ensure that they live a longer life with a much impact on their health. So telehealth and IoT is going to boom in this current scenario in India and abroad, because everyone is caring about health now. So what the system does is it is low cost solution which could stay with the person at every home, at rural area or in urban landscape, and periodically morning, afternoon, evening the person can go and feed their data. So as I plug in the module right now, you can see this is the node MCU or the Wi-Fi module that is connected to the IR sensor right now. There are no sensors connected to it. but I'm going to show you how this module connected to my home network is going to stream data onto a live website. You all can actually log on to this website www.sathi.live/live.php and get to know that it is streaming in real time. So for now, this is the module and this is the web page. So this I'm going to go to the web page and refresh it, right? So you can see the last data, serial number 66. I'm going to put it on live mode. Yeah, the time is 17:15, and right now the time is the same. So this streams data after an interval of every 5 seconds. How does it stream? It is connected to my internet, to my home Wi-Fi network, and then it is pushing data using PHP. I'm using PHP framework right now. I'm not using any third-party IoT architecture. I'm using simple PHP, which is sending data, which is pushing data into the database using SQL, and then from the database, it is actually shown to you on the screen. And then if I show you the code elements, putting it aside, just a second. Yeah. If I show you how it actually works in the backend, then you can see here that, okay, I'm using these 4 libraries. These are my credentials for my Wi-Fi network that I'm giving it to the hardware module. And then, yeah, I am declaring my host. My host is www.sathi.live. This will depend on the domain that you're having, on which you have to actually push the data. And then we move on to this element. This is the crucial element that is doing all the work, because you can see these are the variables that I'm declaring. Right now there's a random value that is going between 1 and 50 as I have selected here. There's no particular sensor data going, but once you connect any sensor with this module, it would actually stream a sensor data. So say temperature, so say humidity, and it will actually send that particular data. So right now I'm sending any data between 1 to 50, any number. And then here you can see there's this variable post data, which is actually having body temperature, heart rate, and SpO2. By this variable, I mean SpO2. This actually tells you the breathing rate of the person, right? And then we start with http.begin. Sathi, this is the PHP page that I have. And then I'm using post method to actually send the data. If you know basics of web development, post method is actually used to feed and send data to the database. Yeah, and as I go to the serial monitor, actually I can see, okay, so if suppose I am switching it on, I'm switching the module on, and it says detected. The IR sensor detects that. Right now it is working on a framework that IR sensor detects it, it starts sending random value. But in place of sensors, when the sensors detect something, it sends the actual value of it. So detected, sending 200. 200 means sent. So yeah, this is how the entire thing works. Just a second, I'll get back to the presentation. Yeah, so do we have some questions here? Okay, so Yogesh Agarwal asked that what role IoT can play in revolutionizing the future, specifically in healthcare. A very good and a crucial question for now, for the time being. IoT in healthcare is at a very nascent stage in India right now. IoT has not been deployed into the healthcare properly, but there are certain companies like 1mg.com or say netmeds.com. These companies are actually bringing uh, teleconsulting with the doctor, but not any telemedicine solution or telehealth solution. So people are using Fitbit, people are using health fit bands and everything. They're actually seeing what their parameters are, but that is restricted to their local, to them themselves. It is not actually validated by any health official or any trusted health setting. It is not there. So after in the post-COVID world where everyone is going to actually focus on health so much, and IoT is a thing that could actually bring down the number of cases and stopping the spread. Because right now, if you study a case, there's a woman. It's just a case study in China that there's a woman, 46-year-old. She was detected positive, and then she was at the hospital for about 30 days. And when she was declared as totally COVID-free, tested twice as negative, she was discharged. But after 30 days, there was a relapse, and the symptoms were growing. But the very fact that the hospital had no connection with the lady, it actually wasn't any, there could be nothing that the hospital could do, the lady could do, because the lady had the satisfaction, oh, I am relieved. But if the solution would have been there, if she would have been diagnosed daily, not by the doctor, not by the any person who's actually busy treating other patients, it would be diagnosed by a system, an IoT system. And if the IoT device see the trend going up, the symptoms going up, it could actually notify the hospital authority about the anomaly, and she could have been actually be treated much early than getting into a critical stage of COVID. So this is how IoT and telemedicine can help people in India. And absolutely, Bharti Airtel has said that this is the right time to actually deploy IoT in healthcare right now. And it would actually boom in the post-COVID era. Every hospital would try to integrate it with their existing infrastructure and help out people. And even I or you could have, you want to have such a solution through which you can actually be at the end of care of a hospital, of your trusted health setting. And yeah, it is actually a very vital element that needs to be there. Yeah. So, yeah. Uh, any more questions? Can we transform microprocessor as microcontroller? See, actually, microprocessors are actually used for a very complex system. It is actually used for, suppose, say, you have to do multiple things at a time. You have to take data, you have to send data, and meanwhile, even process it. So there are multiple processes going on, and microprocessors are not cost effective. They you have to invest a lot of resources into it, but it actually does the work, and it is not as capable as microcontroller. Microcontrollers cannot be compared with microprocessors. It is quite similar. It does the same work, but with a lot different capacity and accuracy. Microcontrollers are small. Microcontrollers are cheap. Microcontrollers can do the work very fast, but one at a time. And microprocessors are much more very different from microcontrollers. Yeah, it cannot be compared, but it both of them does their work with their own elements. Yeah. In a time where when Sugesh asked, in a time where even humans cannot understand each other, is it even possible that the smart devices can understand us and act according to our needs? Okay, yeah. So a very interesting question. So humans are absolutely derived by many or influenced by many other emotions and very different kind of settings, but IoT devices are actually streamlined to just one thing, that it needs to know about you, it needs to care about you, it needs to give you vital information, it needs you to connect with actual trusted sources. So it is not being influenced by any human emotions involved. So it would actually streamline the entire process and it would work for you. And it is actually complementing. IoT is nothing like an artificial intelligent robot. It is something that is complementing your life. So if you're living normal, the usual life, IoT is not coming up and replacing something. It is always complementing it. So in the, as you said, can not understanding humans, IoT can actually understand you, can actually see your behavior, and it can actually analyze your behavior, and furthermore help you with stats, help you with data, help you with further notifications that you should actually see and actually implement so that you live a better life. Yeah, absolutely. Can we get this code? Okay, sure. I'll open source it. It's just a fragment that is really important, which you could actually through which you could actually make IoT devices using PHP. Right now, there are various complex tutorials on internet which could actually let you deploy IoT devices, but with a very complex and a time-taking, uh, uh, proper, not so user-friendly the process is. So yeah, sure. And then yeah, Yogesh Agarwal asked, what is the relevant age to start learning IoT and other emerging technologies? I feel that right now, if you say 5 years ago, IoT was at a very nascent stage. It was being talked, it was being worked out by companies, but not so uh, out in the world. So right now, it is actually everyone knows about IoT. Everyone actually wants to try out IoT, smart home concept is worldwide. Alexa, Google Assistant, everyone is actually buying it. Everyone has smart bulbs which they could control from anywhere, ACs. And so the interest is growing. Companies are investing a lot more on IoT infrastructure, IoT companies. So if you want to get into this field, you have to get into this field right now. You have to actually see how it actually works. You can directly get into IoT and actually develop things. And if you see that there's a lag in a particular field, so say I am developing something, I don't know much about PHP. So learn PHP in the journey. You don't have to start everything from the basics. You can start right now, and this is the right time. And even and from in early stage, so if you're at school, say from class 10th or class 11th, when you actually get the basics of programming, you can actually start with IoT. It is very vital because it is going to open up so many opportunities for you in the future, and people are actually finding such people for job opportunities or hiring or recruiting. What Ruchir Rathore asked, any guidelines for building career in IoT? So building career in IoT, absolutely. You can, first of all, in India, the hardware industry, there are few good players in the hardware industry. It is a very untapped market right now. So if you want to get into IoT, you can. There are people who are actually running such companies. They would actually hire the people who knows about three things. There are three main things: web development, they actually know how to work out with the data; embedded systems, you know the basics of microcontrollers, you know how to process sensors data and connect with it; and third, networking. So these three things, if you know well, if you actually are very compliance with it, so then you can actually you can build your career in IoT, and you have to work on projects. Yeah. Another thing is you try your hands on IoT. Until and unless you build projects, until and unless you fail with such projects, it is very difficult to actually know about the nitty gritties of Internet of Things. So start with projects, start with getting into embedded systems, and you can surely build an amazing career on IoT. Yeah. There's another question by Pankaj Lamba: how IoT can be used with various technologies, specifically cloud computing. Okay, so suppose I'll give you an example that you have your, say, uh, you're working in an oil and gas industry, say, fine. So you, every day, the number of employees that are coming in, that they are working, and you have to actually have a surveillance system that nothing goes wrong, no anomaly goes out there in the site. So what you will do is you'll have basic sensors deployed everywhere in the factory. This is actually being worked out in US, and it is actually being used by such companies. So sensors are there, that those sensors send the real-time data to the cloud infrastructure, Google Cloud Platform, or any or Microsoft Azure or Amazon Web Services. So that goes to these platforms. They have existing cloud architecture, IoT. You can see out Google Cloud Platform, Microsoft Azure, IoT Hub. These are all pre-existing. So all this data goes to one platform. That is the endpoint. And when it goes there, that's the cloud computing infrastructure. And you add the stream. You add the stream analytics. That okay, I want to know what is I have fixed a threshold for temperature. If the temperature goes beyond that, I need the alert systems to go on. I need a notification on my phone that I have to take action upon. So cloud is actually helping you to get data, have it there, and further and processing it to stream it to the second endpoint. Cloud is actually being the aggregator of the data to help the user. So that is how it actually works. Yeah. I hope that answers your question. Sure. Now, we move on to the from where we left on. Okay, so now I'll give you a very interesting example how you can actually relate to. So yeah, first of all, let's just consider this example. How do currency gets produced? We use plates. We use certain plates through which currencies are produced, are manufactured. Creation of currency with plates happen at a particular place. In India, RBI has certain places where currencies actually gets produced. And then first stage, this is the important stage, the currency is being produced. Second, securely transported to the ATMs. So suppose currency is there, where it is produced, if it's there, then it's of no use, right? It is securely transported to the ATMs. You can see the vehicle that is there, properly secured. I mean, totally armored vehicle with the security officials. And then third, it goes to the ATM. When it is added to the ATM, it has been processed totally. It has been added to the ATM, and it can actually then be used by the people to actually withdraw money and use it for varied purposes. We have a lot of purpose for spending money out there in the market. So this is an example. So at this point of time, you might feel that this is not at all relevant with IoT and what I'm telling you right now. But now let's put the same example into something that I want to explain. Okay, so data being created from sensors and feed it to the gateway using IoT. So if data is not being created from somewhere, how are you going to use it, and how are you going to actually help with the existing problems? So right now, what is happening? Manual entering of data. Okay, I say that I am working in a company, the employer wants me to actually manually go and log data about the temperature, about any parameter that he wants me to enter, and actually manage it and analyze it time to time. And this is not at all the efficient way of doing things. So IoT, along with the help of microcontrollers and sensors, actually is creating data and sending it to the endpoint, that is our cloud frameworks. Then it is being transported through blockchains securely, because data is essential, and blockchain is a decentralized way of actually implementing safer transmission of data. And blockchain is used in actually securely transporting it to where? The processing site is where artificial intelligence, machine learning, big data, Hadoop, all these technologies are used. So if data is not created, how will you analyze it? If a particular data set is not accurate, and if it's not created in an efficient manner, how is it going to be analyzed? So with all that, it actually comes to the processing point where AI happens, where machine learning takes place, and the data is being streamed to make it productive, to make it something that people would like to pay for, make it something that people would like to see and interact with. And then this goes to the people, this goes to the user out there for whom this entire framework is created. And they can use it for several purposes, they can use it for varied purposes. And this is what is happening right now in the IoT structure. So this is a triangle that is being created of IoT, blockchain, and AI. And these are the three major emerging technologies right now in India and abroad, which is actually going to transform the entire world in the next 5 years, and is going to create a huge market from a business point of view. Yeah. Yeah, so I would like to actually make you think and tinker upon such emerging technologies. And if, as far as IoT is concerned, these are certain elements, these are certain applications of IoT which you could actually see, and see where actually you can apply IoT and make use of it. Because IoT is an untapped market right now. You can be as creative and as innovative with it, and you can actually deploy. So suppose when internet was created about hundreds of years ago, it was at a very initial stage, it was born there. So the people who actually developed such projects were billionaires in the next 10 years. And the same way goes with IoT. If you actually do something with IoT right now and work on it and research on it, make projects on it, deploy it, or start with your own thing, it would actually work out to be a very beneficial thing for you. So you can actually tinker upon such ideas. There's a quote that if you whatever you want is already there with a number of people. So whatever you want is already, people are already having that. Create something that no one has. Create something that no one has. Only you can have it, and you can actually bring out to the world, and actually people can use it. So yeah, these are some applications that you can tinker upon. You can actually see them: transport and logistics. You can see how supply chain can be improved with IoT and blockchain. Utilities, smart cities, smart buildings. Smart buildings is a very crucial application right now, because sanitization, as well as the normal commute in the corridors of apartments, is a very bigger threat for spread of the virus. So you can come up with such solutions that how it could be more safer way of doing things, and obviously people would like to pay for it because this is a necessity right now. Unless and until you tap on a problem statement that is actually crucial, it is not going to be acceptable by the user. Create something that people needs. And then consumers. Consumer industry is a very big market which has a very big market cap. Wearable for kids, these are something that people have already done, but you can see for some innovative solutions. Industrial, environment, and agriculture. Agriculture, precision agriculture techniques, drones, and various other techniques are being used in USA. But what can you do in India, keeping in mind the literacy level and the amount of uh, tech savvy the people are in the rural landscapes, which is quite not a lot of people are doesn't know of it. So now we move on to the course outline that we'll be having at Zubi, the IoT program. If you want to know more and if you want actually to develop these things and want to deploy, so you can enroll for the IoT program, and this will be the course outline. Module 1, we'll focus on introduction to IoT and fundamentals of electronics. So we'll actually see the introduction of how these systems work, what are the modules in there, what are the frameworks that we'll be using, so all that. Module 2, we'll be seeing embedded systems, as I discussed, microprocessors and controllers. This was a very basic introduction. We'll delve more into it and see the nitty-gritties of it. Module 3, projects and applications based on microcontrollers and sensors. We'll be actually going into making things. We'll be actually using microcontrollers and sensors locally. First of all, in module 3, we'll do it locally. We get this sensor data, we process it locally. We are not sending it anywhere. We move on to module 4, where we'll actually use Bluetooth module, local area network. We'll use it locally. Sensor data is being streamed to our mobile phones using Bluetooth. And then we come on to the final stage where we are actually using Wi-Fi or the internet to send it to say your website, say cloud infrastructure, say Google Cloud platform. You can see it from anywhere, Australia, Spain, anywhere. This is what we'll do in module 4. And in module 5, projects and applications based on web development. In module 5, what I'm basically trying to do is make an entire ecosystem, as I discussed, going from the hardware, going from the Wi-Fi module, going from the endpoint, and then to the front-end website. So after learning everything in the module 4, in module 5, you'll actually be able to have a full-fledged IoT system, which you'll be able to say, okay, I build this, and let's actually deploy it in the field that you want to do. So yeah, this will be the course outline. And yeah, that's it for this webinar. I would like to attend some questions. Yeah. Okay, so Yogesh Agarwal has a question. Do you have any more videos where I can learn about Internet of Things? Okay, so I can after the webinar we'll be sharing some links of some various important videos that you could actually see and learn more on IoT on our Telegram channel for sure. So you can actually see. Then Future Engineer says, I have Arduino videos in Udemy, but don't know how to save them from it. If you know, tell them, I'll share it. Is Arduino good to start for IoT? See, Arduino, the development board, is being used globally. If even a 6-year-old kid can use it, and even $1 million startup uses it for prototyping. If you know how to use an Arduino, you actually know what an embedded system is. You know how to program things. And if you connect Node MCU or ESP8266 to you to the Arduino module, it will be an IoT device. It will be an IoT project for you. So Arduino is the best place to start, and because it starts with basic things, it starts with more curiosity of yours, then going on to a journey of creating industrial devices. So start with Arduino. Start with Arduino connected with the ESP8266, because that is what makes an IoT device, and you can start with it and surely build amazing projects for it. Yeah. So any more questions from the audience? So what is good to start for global level? So let's say right now, health is a very crucial thing, but think upon a problem statement that enterprises right now, the companies right now all over the world, startups, businesses, they are hesitant in calling back their employees, and so are the employees, because employees don't want to get into a workplace where there's a threat of spread of virus. So think of a solution that could actually make it more safe, an identity card or a passport like thing for the enterprise, which would work as an enterprise software. So the person logs data of him, or the person, or it automatically gets logged. Okay, where he has been. Contact tracing apps are there, but they are not as efficient for enterprises, because, and have they gone through the checkups? Okay, my employee, there are certain health plans in an enterprise. So I am the employee, I have given a health plan to all of them. Are they actually following it? Have they gone through the checkup this week? So I can check all this, and I can be assured enterprises would like to pay for such solutions. Enterprises are actually trying to find such solutions of having a safer workplace. So yeah, that could be gone for a global level, and you can actually try that out. Yeah. Yeah. Any more questions? Okay. So I think that's all for today. So stay tuned on our Telegram channel for more such webinars. Okay. There's another question. No, I mean what I should learn for global level to excel in IoT. Try out, first of all, building the hardware module. Try out Arduino with ESP8266. Then move on to PHP. Go on to the second level. And then third, use Firebase or use Microsoft Azure IoT Hub. These are the global solutions that people are building on, and use this for your IoT device. Go and you can go and learn Microsoft Azure components, because I have worked on it, and learn and then execute it. There are various hackathons and competitions happening globally for Microsoft Azure. You can search up for that, and you can actually, what you've learned and you've built, you can actually showcase to a lot of people and collaborate. That's the best way to learn, and that's on a global level. So sure, you can go for that. Yeah. Yeah, so I think that's all for today. So stay tuned on our Telegram channel for more such webinars on blockchain, AI, and many more such emerging technologies. And if you're interested in IoT, do enroll for our IoT program. Thank you and have a nice day.